All right, welcome back to Channel 9. We're here with some esteemed colleagues. It's apparently the Danish
That's right.
panel. You just pointed that out to me. All the language people come out of Denmark now?
That seems to be the case. Yeah,
Absolutely.
at least the good ones.
Awesome. Well, I've got Mads Torgersen. Needs no introduction. Anders Halsberg, who needs no introduction. We're talking about languages, and I will hog all 30 minutes of their time if you do not ask questions, okay? Because love these guys, love the work they've done. A lot of the stuff that you've done, I've used throughout my entire career. And so please ask questions or I will hog them. So the first question I want to ask you, and it was kind of a funny question because I asked you before and the way you answered it was like, well, is there any new things with TypeScript coming out of build?
No, we're not announcing anything here, but like 2.9, I think release candidate is going out next week, I think, or maybe this week. But like I told you, we release every 2 to 3 months, so there's always a new release coming out.
Like I'm looking for excuses to have you on every 2 months. This might be. Like, I'm actually out of town every 2 months. What about you? What's new with C#?
Yeah, C# is a little more old-fashioned. I think we only released 3 or 4 times within the last year.
Which is a lot more than it used to be.
It is a lot more than it used to be. We went on kind of a release spree and released 3 point releases of C# after C# 7.0, so you can kind of guess what they were called. And we're actually 7.3 actually comes out today with the latest release of Visual Studio 15.7.
So what are some things we should look for in the new 7.3 release, and then we'll get into TypeScript stuff.
7.3, it's kind of a small release. It rounds out some of the experiences we started in 7.2 with a lot of the safe, low-level performant features that we put in. We also removed some old constraints and limitations of C# that have just been bugging us forever since his time.
He's right there.
You can now have delegate and enum constraints, and we removed some of those weird things in overload resolution where we pick the wrong thing and then we complain about it. We stopped doing that. So you know,
I remember those issues.
Yeah.
So this is cool because like it's cool to see like the new stuff, and when you're looking at the new stuff, are you thinking, boy, man, I wish we would have done this before or had the capability to do this before?
Well, I mean, I don't know. You know, like are you in terms of TypeScript? You mean?
Yeah, C#. C#. You're looking at the new stuff, and you're like, yeah, that's something that I wanted to do, but
there are so many things that we wanted to do, but we also we're very serious about backwards compatibility.
Right.
And often the things that we want to do are things that would have backwards compatibility impact, and therefore we haven't done them. Do you know what I mean? So it's always like a careful balancing act there. You know, is the aggregate betterness that you get from this feature worth the pain that you would cause by breaking stuff? And rarely does it come out in favor. You know, So more and more, as a language ages, more and more your job becomes like finding clever ways to sneak in new features in ways that don't actually break existing code and patterns, right?
And I remember I took a compiler's class, and it was, I mean, and we did this video together where you're like, and that's not even how we do it anymore, Seth, which is...
It's done very differently now because there's such a focus or emphasis on tooling and using the compiler as the intelligence behind the tooling, but the performance requirements of something like that and the responsiveness requirements of something like that means that you can't really engineer compilers in the traditional multi-pass sense with like separate front ends and back ends and yada yadas, you know, that take an afternoon to compile your code.
Yeah.
You need to deliver answers in 100 milliseconds. And that's, you know, that takes for you to do it in a very different manner, right?
Yeah.
Which is kind of cool. I mean,
it is really cool. I mean, compiler today essentially does all the same things. It does the same tasks. It still lexes and parses and does type checking and all that. It just doesn't do it one after the other in big bulk, right? It does it a little bit at a time every time you press a key. It does a little of all of them.
It's like the difference between waterfall and agile, right?
Yeah, yeah.
What? I just made that up.
Don't do any work you don't have to do. That's really what the whole game is about.
Yeah.
And if you have done some work, then make sure you can reuse it for as long as possible, right? I mean, so.
Man, that's amazing. And like the older I become as a programmer, the more I'm like, you don't need to invent everything all the time all over again.
Yeah.
Which is...
laziness is a good thing. In life as well as in programming.
That is what drives our The tooling is all driven by lazy techniques.
That's
yeah.
amazing.
Yeah.
All right, let's talk about some of the enhancements that we're adding in 7.3. Was span of T one of them?
In a way, yes. 7.2 and 7.3 enable the type called span of T, which is not, in the language, it's in the framework. It actually released as a release candidate today as part of .NET Core 2.1. But it's a type that can only work together with some language enhancements. So it's essentially, span of T it's like an array. It represents a contiguous segment of some type in memory, but it doesn't have its own memory. Instead, it's a window onto some other memory.
Are you trying to say pointer in like a not so
Well, it's a pointer with a length. It's a pair.
It's a safe pointer with a length.
Okay.
Right. So it's completely safe, but it lets you pass around chunks of memory without copying them. And also, if you use read-only span without allowing people to modify them, right? So you're always worried about passing your array to someone else because they might poke at it and ruin it for you. And so it's both safe in terms of you can choose read-onliness, and in terms of having a length that gets checked at runtime, so you don't index out of bounds.
Right.
And also that it's not just limited to unmanaged, like low-level, unsafe types, but you can use it on any type that you like.
And that's kind of cool because if I remember right, when you are like doing substrings, you're like recopying stuff, right?
Yes. A lot of the things you do with strings and sometimes with arrays are incredibly inefficient today because there's copying going on all over the place, as well as allocation. And both of those you can essentially eliminate with some clever use of the span of T type.
And that's interesting because you said because maybe you can help me separate the two, and for the viewers too, because you said it was a language feature and a framework feature, or parts of both. Can you explain that dichotomy?
So it's a framework type that requires some new language features in order to work correctly. So there are two things about it. One is that when you index into a span, what you get back is actually a storage location. It's like a ref. You get a ref back from indexing that when you read to or write from, you're actually going all the way into the storage behind there. So it uses the ability of C# to return ref and ref read-only references to storage locations. But it also has, because it's actually able to reference memory that's on the stack or even unsafe memory that's outside of the garbage collector's purview, it has its lifetime tracked just like a ref, in that a span cannot be stored in the heap. And it has all the language makes sure of all of that. It makes sure of all the stack safety, if you will, that it only can survive until the stack frame that the storage originally got created on goes away.
So there's no garbage collection with the span because it's always in the stack.
Exactly.
Oh, I see. And like the thing about .NET is it's really cool, right? Because I don't like cleaning up after myself in real life and in my programming languages, right? And so, but sometimes if you're allocating a lot of stuff on the heap, the garbage collector needs to do its job. And sometimes if you're messy, but you're saying with span of T, you're able to address memory in a way that's safe as well as not heap allocated. Yeah,
the memory doesn't have to be heap allocated. It can be. You can use a span to represent a slice of an array if you want to. But you can also, and this is another language feature that we added, you can stack alloc an array of 20 elements, for instance, an array of 20 strings or whatever, and then you can have a span to that, and you can pass the span around, but once you leave the stack frame that your stack allocated it on, you can't pass the span back out. It can't survive that. And so the language rules are in place to ensure that that is all safe, and that nothing survives. You're never left with a dangling reference to something that doesn't live anymore.
And that's cool because whenever you're looking at adding new features, there might be something where the language changes for the compilers and stuff, but there's also stuff that you have to introduce in the framework as well.
Yeah.
Which is kind of cool.
Yeah, it's often in tandem, right? Some framework features, some language features, even occasionally some changes to the runtime, though we haven't done that in a long time.
Cool. All right, a couple of questions from people. Scott friend says, what is the most underused C# feature you think people should be using more? This for both of you.
Underused C# feature.
Like you're on the spot.
Ooh. See, you tend to not think about those so much.
Yeah.
I actually think that people don't use link enough.
Don't use what?
True.
Language
Maybe.
integrated query.
Yeah. Yep.
So
That's definitely a nice feature, and we spent a lot of time optimizing that too.
Yeah.
I remember. So
Yeah, we're really
so,
disappointed
yeah.
after all this time we spent.
gosh, man, why did you spend all this time on it and you're not? Link is actually very powerful because it allows you to start thinking in a functional way too,
Yes.
which was really, really cool. And the way you lazily interpreted some of the enumerables was amazing. Because remember the first time I ran it and I like set something equal to something, where's my list of things? It's
Right.
not there, right? And so that was actually a really cool way to start thinking functionally.
Yeah, and one of the things people didn't realize as much as they should have, or don't, is that we have things like as parallel. You go up to a collection, you say dot as parallel, and then the queries you do over that are actually parallelized and distributed over all your cores and load balanced in various ways. That is fabulous.
For doing k-means algorithm. For
Yes.
doing k-means clustering, and it worked perfectly.
Excellent.
And I could see all my CPUs go boo, and I was like, those
That's
guys
so
and
beautiful.
gals that work
and
on
then
it.
you don't have to think about threads anymore. You just say as parallel, and all the data parallelism happens for you.
Awesome. Next question. Won't there always be breaking changes or deprecated features in any programming language?
A first shout out to David I asking this question here. And he and I used to work together a long time ago
Really?
in Portland. Oh yeah.
Oh,
Yeah, yeah.
man.
You should take that one then.
Yeah, won't there? Well, yes and no. They'll be deprecated, but I don't know about breaking. I mean, I think certainly it's always been our operating mantra on C# and TypeScript that, you know, you don't break people's code.
Right.
Because that's really sort of like breaking the contract you have, the unwritten contract you have with the user, which is you should be able to upgrade to the latest and greatest and still have your code compile.
Right.
But of course it is, when you're building a type checker, it's sort of a fun, strange dilemma to be in, like for TypeScript, right? Because our job is to give you error messages.
Yeah.
Right? And hey, you know, as we get better, we give you more error messages, but that technically breaks your build, right?
Yeah.
So how do you handle that, right? And so you got to put things under flags that you have to opt into, or you have to have ways of either saying, I don't want to opt into any of the new checks, but I want you to check everything the same way that you're used to, right? Or just give me pain every time. I want to opt into the latest and greatest, and then I can opt out from there if I do. Do you know what I mean? And so
That makes sense. Like,
so this actually took us a while to like get that puzzle together, but that's how TypeScript works now. So we have this sort of strict master switch where you can like say, boom, yes, give me all of it.
yeah.
You know, and find some errors for me, right?
But
or you could stick with where you are and then individually opt into the new features.
Right.
But interestingly, you never change the semantics of the language. It's always about, okay, I got some compiler errors that I didn't, and I can opt in and out of those.
Right.
But no matter how you set your flags, the language means the same thing once it gets running.
That is in spirit, yes. But there are always you know, but generally speaking, yes.
Right.
Yes. That is
And that's interesting because like TypeScript is designed to break stuff. Like, and I mean that. Like if I go freewheeling JavaScript and I just start writing JavaScript, and then I say, oh, I'm sorry, I'll compile it with TypeScript, it's going to it's going to say this is wrong. Like, I mean,
well, it's going to say
it's me.
this
I'm
could
writing
be wrong.
it.
This could be wrong,
Yeah.
right? I mean, and that's the thing. Often, when you apply TypeScript to an existing code base, you're not going to find things that are wrong, because if they were wrong, you would have probably found them, you know, the hard way,
Yeah,
right?
right.
I mean, by running the code and having it blow up. The thing you find is that you're going to find latent issues that, oh, I guess I never actually had these two stars align, and then this could happen, right? But I didn't have a test for that. But then, once you start adding types, then you'll actually see, you know, an increase in your velocity, because when you then do make mistakes, they get the big mistakes.
Yeah.
Then they get called out right away, and
Yeah.
then you don't even go down the path of having to spend 2 hours debugging and then finally slapping your forehead and going, oh my God, of course, that should have been a 4 of instead of a 4 in, or something silly like that, right? Where you can stare at this code all afternoon and still not see it, right? So
One of the fun things is one time I came to your office to talk to you about something, and we were just releasing a new TypeScript version, and we compile TypeScript with TypeScript, I think. Is that right? Like,
Yes,
And you
yes.
said you turned a check on, and you're like, oh, well, there could be a bug in the older version of it, and it was
well, yeah. No, we're about to actually. We'll probably do that. We'll probably merge that pull request real soon now, where we're switching to strict null checks in the compiler itself, which for a variety of reasons we haven't done, just because we've been too busy implementing other features, right? But yeah, they definitely found a few places where we go, yeah.
That doesn't seem right.
Yeah, yeah.
All right, so there's people asking questions, and I promised I would ask. Question for Mads, would you ever get to a point where you would draw a line in the sand and say, legacy C#, and start moving forward with new features that require legacy breaking changes? Oh man, he's like, huh, what do you say, Mads?
I don't think so. I think what we found is that we may actually have had doubts about how long can you keep evolving a language like C#. And what we found is, actually it turns out that keeping on evolving it is just fine. As long as we're careful and tasteful about it, and we don't just willy-nilly slap the sort of the feature of the year in. So if we're judicious enough about how and when and why we add features, we can keep doing this for a long time without breaking anything. I think the inflection point comes not at a point where we say, okay, let's throw some things out and start a new C#. That's when things have changed so radically in the space of domains that people program for, or in programming languages themselves, that we're like, there's no way that C# can keep up anymore. Like this is just something fundamentally that this is an nth generation language, and now there has been a paradigm switch, a shift that we just can't follow anymore. Yeah. And at that point, you don't go and make C# next, you go and make another language.
Exactly. Everyone just starts using Haskell at that point, right?
Yeah.
Yeah, I think that, but until then, until like C# becomes fundamentally and inherently irrelevant, we can work around those things, and we can keep evolving it in a compatible manner. We are going to add our first compiler switch in the next version of C#, so inspired by TypeScript to some degree, and definitely learning a lot from it. We will add stronger checks, optional stronger checks around nulls. So we're going to have our first compiler switch that turns a compiler check on and off. We've avoided that so far, and we'll go down that path because this is an important problem to solve. But we're never, as far as I'm concerned, we're never going to break the semantics of C# in another version. That's just never worth it. I mean, how many billions of lines of C# code are out there? Just can't do it.
Yeah, I've written a couple myself.
A couple billion, yeah.
A couple trillion. Are there any performance improvements in the new version if possible? Can you describe some of them? You described some of them with span of T. Anything else?
Assuming that this is about C#, I guess, since well, the span of T work comes as part of a package with many performance improvements in it. There are also a few other things, like in 7.0 we added local functions which improve performance over using lambdas.
Right.
I mentioned the ref work that is related to span of T as well. There are a bunch of ways in which you can write more performing code in C#. C# itself, I don't think we changed how, not in any big ways. We always do little tweaks, but I don't think we changed a feature to be this much more, this much faster.
But .NET Core has a bunch of optimizations.
.NET Core itself, so when you get further down there's a bunch of optimizations.
Right.
And actually, one of the things that would be fun to look into one day, we've not touched the runtime. We do all kinds of optimizations in the runtime. Garbage collection gets better and better, for instance.
Right.
But since generics, we haven't really implemented a language feature directly in the runtime with new IL.
Right.
And that's an opportunity for the future, maybe. But one thing that we often did instead is to do compiler tricks. When we did lambdas, when we did async, and so on, the compiler writes some really complicated IL because the underlying runtime does not know about async. It does not know about state machine.
Right.
Maybe one day, if we could add new instructions to IL that knew about state machines, we could have the compiler do a more straightforward compile to that, and then the runtime, knowing everything it knows as it's running, could do a much better job optimizing the performance of that. So that's something, maybe sometime in the future could be cool to do.
But at that point in time, it's like there's no change to the language. Everything still works the same, it's just faster now.
Exactly. I would love to be able to do that kind of thing one day.
Yeah, cool. All right, next one. Are there any more functional features coming soon into C#?
Functional features. Well, the nullability sort of kind of comes a little bit from
control flow analysis. You could sort. Well, I mean, it's not per se a functional feature, but
right. We also async streams is also kind of functional a little bit. It's sort of inspired there.
I mean, pattern matching was I mean,
We
obviously.
already added pattern matching.
Yeah,
We're
but
going to continue adding it, including an expression version of switch is on the table right now. So that's definitely going in the functional vein of having expression-based language features and control structure. So we keep dripping them in all the time. There's a lot of good stuff to harvest still in functional languages.
Cool.
Yeah, well, we've been certainly harvesting some of it.
From Greg, how do you go about balancing C# readability with popular syntactic sugar?
Well, I guess that's another one, another C# one. Well, it is exactly that. It's a balance, right? So so hopefully syntactic sugar, if it reduces readability, then we shouldn't do it. Right? Syntactic sugar should be about increasing readability,
right?
As well as writability. A syntactic sugar that just lets you write something with fewer characters is not really good if it makes the code inscrutable.
Right.
So the idea is to actually take away some of the details and make the intent stand out. That's good syntactic sugar. And at that point, they're not really in conflict. So that we try to limit ourselves to that kind of thing. And then, yes, it still means that oftentimes the language gets bigger, there's more to learn, more ways of saying the same thing. So that kind of grows the language at the expense of maybe making it easy to learn. And that's always a balance. We tend to be, if something is useful enough and makes the code nicer and easier to write and easier to read, we'll err on the side of complexity a little bit. We'll add the feature rather than saying that we have a simple language where you can only do things one way.
Cool.
Because professional developers use it, and they gotta write nice code every day and have productivity and so on.
I love it. So we have about maybe 7 minutes left. We'll get this question here in a second. Let's take a look at the future of the respective languages you work on. What are we looking to do in TypeScript moving forward?
Well, so in 2.8, which just shipped about a month ago, we just did conditional types, which is sort of yet another step in the ever-increasing expressiveness of the type system, and it's become quite expressive at this point. I think going forward, you should expect to see us doing a lot more refactorings because we now have a very rich substrate to build that on and an extensibility model to add them in, and now every release we expect to have at least a few of those. There's still some big questions that we're looking at attacking probably in 3.0. We're gonna probably do composite projects, which is the ability for projects to formalize the notion of projects referencing other projects, so you can have like really big, I'm not going to call them solutions because they're a different thing, right? But like people call them mono repos, for example, where you have like a whole bunch of different projects in a single repository. And yet you want to be able to run builds over them. You want to start the compiler in watch mode and you want to be able to do code navigation and refactorings over these big dependent projects, and that takes a lot of work. And I'm not saying that we're going to get all of that done in 3.0, but we're gonna start to make inroads on it because we're seeing some very, very large projects now that people are writing in TypeScript.
Now, here's a philosophical question I'm going to ask, and you don't have to answer if you don't want. How much should the front end do versus the back end, do you think, just in your opinions?
Of a compiler?
No, I mean like because I'm seeing JavaScript projects that are really big.
Oh, I see what you're saying.
Right, like and like I built my first JavaScript thing like many years ago, and it was jQuery, and it got unwieldy very fast.
Sure.
Now with the modern things like TypeScript and Angular and Vue and React, it kind of takes away that diminishing returns that I had a couple of years ago, probably 8-10 years ago. What do you think?
Well, I think it's very hard to deliver one answer fits all here because it very much depends on where's the app going to run, what kind of app is it, what kind of connectivity can you expect to have with this kind of app in its core scenarios, et cetera, right? I do think that there are things happening in JavaScript that allows you to structure even client apps as a multi-tier app, where you can have these progressive web apps that run, web workers on on the client that looks like you're talking to a server, and then you just sort of switch between the the cloud version or the local version, depending on your connectivity, right? And so the architecture as such is malleable as well, right? So it's not even clear what front and back end means anymore there, right? So
and that's, I mean, that's an interesting, and I didn't even like think about, oh, then there's the Electron stuff, which is definitely like a software project that you're writing that's not designed to be front end anything. It's just an application, right?
Sure.
So cool. All right. So from my friend Avi Avni, he's in Tel Aviv. Hi, Seth, Mads, and Andrea. It's really great to contribute to the compilers. What do you think about generic attributes? Generic attributes.
Generic attributes.
We're looking at attributes in C# that can be where the attribute class itself can be generic. I think we're looking at that. There's nothing actually preventing it other than it never really worked, and so
there is that. I mean, that's
well,
like a tiny problem.
We never surfaced it in the language, and so it was never really battle tested, and so it might well be that if we turned it on in the language, there would be a long-standing bug, or it wouldn't work down level. And so we had a couple of times before where we turned on a feature that should just be slam dunk, and it turned out that there was some subtle bug in the runtime that nobody's discovered because the feature wasn't turned on.
I mean, I think that the trick with that one is going to more be the encoding of it, right? Because it's that attributes are encoded differently than regular types, right? I mean, so.
Right, but we've talked to the runtime team, and there shouldn't actually be anything, in principle, there shouldn't be anything wrong with representing it. So we may get to that one day.
Awesome. All right, we've got like 2 minutes left. 2 questions, and we'll finish with Dart methods, cascades. Do you think we can see something similar in C# TS in the future?
So I'm not super familiar with that terminology. I think it is probably the same as the pipe operator, which is already a proposed feature for ECMAScript. It's working its way through the committee. I think it's at stage 2. We will implement it once it reaches stage 3. So yeah, I mean, that's sort of the just like you can have dottable APIs, right? I mean, it's more of a formalization of that is similar to what F# does.
Oh, like the pipe arrow?
Exactly, yeah, the vertical bar arrow, yeah.
That's cool.
So that's coming to ECMAScript, it looks like, and therefore it'll come to TypeScript, yeah.
What about C#?
Maybe. We talked about it a little bit, but we haven't, hasn't kind of gone to the top of the priority list.
Cool. And last question, could TypeScript compile to WebAssembly?
I've been asked that a lot. It's really not a question you can answer because the question doesn't make sense, because we're talking about 2 different abstraction levels here. The way you should think of a WebAssembly really is like, imagine that you had a 6502 emulator built into your browser. Or some other processor architecture, whatever, it doesn't matter. But it's like literally, it's like a machine that has memory and an instruction set, and you can put stuff into its memory, tell it to execute at a certain address, and when it stops, you can take stuff out of memory and see what it did. That's WebAssembly. It is, and it is useful for compiling C applications into a machine architecture that runs inside the browser, but you're literally living inside a sandbox in a whole different universe, and the only way you communicate between these things is by putting stuff into memory and taking it out again.
I see.
Like poking bytes into memory, right, and peeking at them again, like. So it's not, TypeScript is JavaScript. And so, no, it doesn't make sense for TypeScript to compile to WebAssembly. But TypeScript can integrate with WebAssembly. But WebAssembly is intended for running low-level machine code in a sandbox inside your browser.
In essence, you're like, there's no way you're ever going to have like a pointer in JavaScript to
There is no garbage collection in WebAssembly. There are no objects. There are no strings. There's nothing. There's memory locations and machine instructions. That's it.
Oh my goodness.
Yes.
And so if you want to optimize something, use the right language for the right thing, and WebAssembly
Sure. If you want to run machine code in your browser in a sandbox to do compute-intensive stuff like bitmap manipulations or rasterization or whatever, or some games that do frame updates, right, which is really like manipulating a bitmap, sure.
Awesome. Well, we're out of time. It goes by really fast. Thanks so much for being with us.
Thanks for having us.
Thanks so much for watching. We're going to cut over to a session right now. See you after the break.